The most significant discovery humanity could ever make won't be a little green alien waving from a spaceship, but an absence of light in the vast cosmic ocean. Spotting a truly advanced civilization might not involve direct communication at all, but rather the subtle, telltale signs of a colossal engineering project. If we ever confirm a distant star is surrounded by something like a Dyson Sphere, it would redefine our place in the universe. This isn't science fiction anymore, it's a testable hypothesis with profound implications. Imagine astronomers detect a peculiar star, one that dims and brightens in an unnatural asymmetrical pattern, hinting at something immense orbiting it. This isn't just a planetary transit, instead, the star's entire light output appears to be systematically harvested. Such an observation would immediately trigger frantic follow-up studies from every major observatory on Earth, scrutinizing every photon. We would be witnessing the first undeniable proof of a Type II civilization. The key signature for such a megastructure is not visible light, which it would absorb, but rather an excess of infrared radiation. The Dyson Sphere, designed to capture stellar energy, would radiate an enormous amount of waste heat into space, appearing as a cold, glowing shell in infrared spectra. This distinctive thermal fingerprint, a faint infrared glow where a bright star should be, would be our first solid evidence. Researchers would quickly pinpoint the star's exact coordinates. While the infamous Tabby star, KIC 8,462,852, showed unusual dimming, its irregular dips were eventually attributed to swarms of comets or fragmented planetary debris. The true Dyson Sphere, however, would exhibit a far more systematic and complete occlusion of starlight, combined with a colossal infrared excess that Tabby's star never displayed. The sheer scale of energy capture would be unmistakable, far beyond any natural astrophysical phenomenon. The concept of a Dyson Sphere was first proposed in 1960 by physicist Freeman Dyson in his paper, Search for Artificial Stellar Sources of Infrared Radiation. He theorized that advanced civilizations would require vast amounts of energy to sustain themselves and would eventually need to enclose their parent star. His elegant solution provides a clear, testable prediction for how we might detect alien intelligence from light years away. Dyson himself envisioned not a solid shell, which would be gravitationally unstable, but a Dyson Swarm, countless independent habitats, solar collectors, and power stations orbiting a star. This modular approach allows for gradual construction and offers resilience against impacts or failures, making it far more practical and stable than a single rigid structure. This decentralized megastructure could expand over centuries, becoming increasingly efficient. The discovery of a Dyson Sphere would unequivocally confirm the existence of a Type II civilization on the Kardashev scale, a civilization capable of harnessing all the energy output of its home star. Our own civilization currently ranks at a mere 0.73 on this scale, still relying on fossil fuels and limited renewable sources. A Type II civilization represents a level of technological mastery almost beyond our comprehension, controlling energy on a stellar scale. To put the energy output into perspective, our sun emits approximately 3.8 x 1026 watts of power. A Dyson Sphere could capture nearly all of this, providing an unimaginable energy supply for countless millennia, powering computational processes or interstellar travel. This amount of energy would dwarf humanity's current consumption by trillions of times, enabling feats of engineering and computation we can only dream of. Constructing such a megastructure would demand an incomprehensible amount of raw material. Estimates suggest that building a complete Dyson Swarm around a star like ours would require mass equivalent to a large gas giant, perhaps even Jupiter itself, or countless asteroids. This material would need to be meticulously deconstructed and re-engineered on an unprecedented scale. The engineering challenges are staggering, involving the precise manipulation of entire planetary bodies and their redistribution into orbital structures. Imagine mining operations dismantling the moons of Jupiter or the asteroids in our Kuiper Belt, then transporting and fabricating these materials into intricate collectors and habitats. This would represent the pinnacle of industrialization, far beyond anything we could conceive. The timescale for constructing a full Dyson Swarm could span millions of years, even for a highly advanced civilization with automated systems. This implies that the builders we observe would likely be ancient, possibly having evolved over vast cosmic epochs, far longer than humanity has even existed. Their existence would mean they have overcome countless existential threats. Upon confirmation, the discovery would fundamentally reshape every field of scientific inquiry. Astronomical models would need immediate reevaluation, as the presence of such structures could bias our observations of stellar populations and galactic evolution. We would have to start looking for other technosignatures differently, understanding that advanced life might hide itself in plain sight. Communication attempts would immediately begin, likely using powerful radio telescopes like the Arecibo Observatory before its collapse, or the 500-meter aperture spherical telescope, FAST. The sheer distance, potentially hundreds or thousands of light years, means any message would take centuries to reach them and for a reply to return. Imagine a conversation unfolding over millennia. The Great Filter Hypothesis, which posits an obstacle preventing civilizations from reaching interstellar travel, would gain a new dimension. If these aliens built a Dyson Sphere, they may have already passed their filter, or perhaps the filter lies further ahead for them. The implications for humanity regarding our own long-term survival would be profoundly unsettling. Philosophically, this discovery would shatter humanity's anthropocentric view of the universe. The realization that we are not alone and are perhaps technologically primitive compared to others would force a profound reevaluation of our purpose and destiny. Our entire understanding of consciousness and intelligence would be challenged by their very existence. Economically, the discovery could trigger a global space race like never before, accelerating asteroid mining, terraforming research, and interstellar propulsion studies. The existence of a civilization that mastered stellar energy would inspire a frantic effort to achieve similar feats, transforming our entire economy into a spacefaring one. Earth's resources would suddenly seem trivial. Politically, the implications are immense. Nations might unite in shared wonder or descend into rivalry over potential contact protocols and resource acquisition in our own solar system. Global governance would face unprecedented challenges and opportunities in coordinating a unified response to extraterrestrial intelligence. The concept of humanity would take on a new, urgent meaning. Religions around the world would grapple with the existence of alien intelligence, challenging doctrines that often place humanity at the center of creation. While some faiths might adapt, others could face existential crises as their foundational narratives are reinterpreted in a universe teeming with life. New spiritual movements could also emerge, focused on cosmic transcendence. Scientifically, the implications would be revolutionary, potentially unlocking new physics or engineering principles far beyond our current understanding. Observing the Dyson Sphere even remotely might reveal how to manipulate gravity, harness exotic energies, or achieve breakthroughs in material science that currently seem impossible. This would be the ultimate Rosetta Stone. The Fermi paradox, the contradiction between the high probability of extraterrestrial life and the lack of observational evidence, would suddenly have a partial answer. The reason they haven't visited us might be because they are too busy building megastructures around their own stars, living within their self-contained stellar empires, perhaps too advanced to notice us. The fate of the enclosed star itself would be a fascinating area of study. While its light and heat are contained, its internal processes, like nuclear fusion, would continue unabated. The sphere would simply manage the star's energy output, ensuring its longevity or perhaps even steering its evolution for specific purposes, extending its usable lifespan significantly. What motivations would drive such a colossal endeavor? Perhaps survival against a cosmic threat, the need for unlimited computational power, or simply the desire for an eternal, self-sustaining habitat. The builders might represent a post-biological intelligence, their consciousness uploaded and residing within the sphere's vast computational network, beyond mortal constraints. Consider potential defenses built into a Dyson Sphere, systems to deflect rogue asteroids, protect against gamma-ray bursts, or even shield against hostile alien civilizations. This colossal structure might be a fortress, ensuring the long-term survival of its inhabitants against the myriad dangers of the cosmos, a monument to their enduring will to exist. The long-term evolution of a Dyson Sphere could be staggering. Over billions of years, it might gradually incorporate entire planetary systems, becoming a multi-layered, self-repairing celestial machine. It could even be engineered to migrate through the galaxy, moving its entire star system to avoid galactic hazards or to seek new resources, a true cosmic arc. The dark forest theory, which posits that intelligent civilizations remain silent for fear of attracting destructive attention, would become an immediate concern. While a Dyson Sphere is anything but quiet, its builders might be so advanced as to be impervious to threats, or perhaps so isolated that they never considered the risk of being found. New search strategies would be developed, focusing on different types of infrared emissions, varying stellar dimming patterns, and even gravitational lensing effects from immense structures. Future observatories, like the James Webb Space Telescope's successors, would be meticulously designed to hunt for such technosignatures across the Milky Way and beyond, transforming SETI efforts. Ethical dilemmas surrounding contact would become paramount. Should humanity attempt to make contact, risking an unknown response, or should we merely observe from a respectful distance? The decision to engage with a Type II civilization would be the most significant moral and strategic choice our species has ever faced, with irreversible consequences. Finally, the discovery would force us to confront our own future as a species. Could humanity ever achieve such a feat, becoming a type II civilization ourselves, enclosing our sun in a vast network of habitats and collectors? The Dyson Sphere would stand as both a beacon of hope and a terrifying reminder of our current technological infancy. If this exploration into cosmic megastructures has sparked your imagination, hit that like button and subscribe for more mind-bending journeys through the universe. Tell us in the comments, what do you think would be the first thing humanity should do if we confirmed a Dyson Sphere?